All right, in this video, what we're going to do is we are going to go over pulling data from one table. We're going to do single table queries. And while we do that, you are going to be able to see that a lot of the operators and clauses that we learn for our single tables are going to bleed over into almost everything we do. So there's quite a bit of information here, and what I'm going to do is just do one query after another, explaining what's going on. And so for these examples, I'm going to use the Solmeris database, the condo one. So as you're watching this, you might want to open up to chapter 1 to look at those tables and play along if you want to. You can actually visually see the data that should be returned and that actually is returned. So we start with the select statement, and the select statement is fairly simple. You tell the select statement what fields you want to retrieve, and you tell it from what table you're going to select from. One thing to note, that if you are going to select records based on certain criteria, that doesn't have to be in the select statement. The select statement really is controlling what fields are going to show up in your output. So even if you select based on, how many customers have a balance over 5,000, you don't necessarily have to show their balance in the output. You can just show their first name and last name if you wanted to. But in a lot of these examples, I'll show the fields that we're selecting on, simply so it's easy to see that our query worked. So we're going to start out with the simplest one. And again, I'm going to paste a lot of these in so you don't have to watch me type them and make errors. So the first statement we're going to do is we're going to select asterisk, which is select all fields from the owner table. And when we run that, I'm going to go ahead and choose the run script right here, which is the little piece of paper with the arrow on it, so I don't have to keep highlighting things as I cut and paste these things in. So when I click that, what it does is it selects all of my owners in my owner table. So it really duplicates whatever you would see in chapter 1, I think on page 15. Okay, because we selected all the owners. We didn't say only certain owners. We said just give them to me all. So the next thing we're going to do is we're going to tell it specifically what fields to fill. So this one right here pulled all the fields: the owner number, last name, first name, address, city. It pulled them all. But if I want to limit that, I can actually, in the select statement, specify which fields I want to use. So in this case, I'm going to separate those by commas. So I have the select statement. I want the first name field and the last name field from the owner table. And so when I run that, no, I have an error. Let's see what happened. Oh, I highlighted that instead of clicking the script. So let me go ahead and do that. And so now notice our output still returns all of the owners. We haven't whittled it down to a certain set of owners, but it did just show us the fields that we asked for. But the meat and potatoes of getting data out of your database is selecting certain records based on certain criteria, and that's where the where clause comes into place. So I'm going to go ahead and put in a where clause. So we're going to select all from the owner table, but we only want to return records where the owner lives in Florida. So we have the where statement, we have the name of the field, and we have the value that we're looking for. So in this case, we're going to use an equal sign. And because we're looking at string data, it is going to be enclosed in single quotes. So with that highlighted, we run that. We get all of our fields because we have select asterisk. But if we scroll over and look at our state, it has only returned the owners that live in Florida. Now, your book goes over all the operators: equal, greater than, equal to, less than, and I'll integrate some of those into the examples coming up. But you do need to know the operators that are included in the textbook. It's also reviewed in the notes PowerPoints for this section. All right, moving along, let's go ahead and again use a different operator and a different table. In this case, let's go ahead and switch on over to the condo unit table. We're going to select these specific fields, and we're only going to select records where the square footage of the condo is greater than 1,500. So let's go ahead and run that. We have our location num, our unit num, and our square foot. And we also notice that in our square foot column, there's nothing that doesn't meet the criteria of greater than 1,500. All right. Expanding on that, we have the concept of compound operators. We can and, we can or, and we can not. And just to review, when you and something, you're getting more specific. If I have two criteria that are anded together, that means that both of those must be met to be selected. If I or my two criteria, I'm opening it up and we'll get a bigger record set probably, because only one of the criteria in my or statement has to be met. And finally, not is just meeting the not statement. So let's go ahead and work with an and first. And we're going to do the same exact query and just change the and to or. So what we're going to do is we're going to go ahead and stick with the condo unit table. We're going to select the location num, the unit num, the square footage, and the number of bedrooms from that table. And to be selected with our where clause, the square foot has to be greater than 1,000 and there have to be 2 bedrooms. Now notice in this statement too, I'm comparing to a number. In the last one I did equal and then I had FL for Florida in double quotes because I was using string data, but here I'm using numeric data, and so I will not put that information in single quotes. So for this to be selected, square footage has to be greater than 1,000 and bedrooms has to equal to 2. So what'll happen in this is our bigger condos that have 3 bedrooms and larger square footage won't be selected because they don't meet the bedrooms equals 2 clause. So let's go ahead and run that. As you see, all of our square footage is above 1,000 and only condos that had 2 bedrooms were selected. So I can just show you what I mean by changing that and to or. It doesn't matter if it's an uppercase or a lowercase, it's just for consistency's sake. So in our first query, we fetched 6 rows. This should fetch more because we're going to get all condos where square footage is greater than 1,000, regardless of how many bedrooms they have. And we're also going to get bedrooms that have, or condos that have 2 bedrooms but didn't meet the square footage. So we should get more than this 6 that we had in our previous query. So we run it. This time we get 10 results because, as you notice, we have 3 bedrooms that are selected because the square footage is over 1,000. And let's see if we have any 2 bedrooms that are less than 12. Let's do less than 1,200 just to make it work. Whoops. So as you can see, we have a bedroom. We have a 2-bedroom here that isn't higher than the 1,200. Okay, and it was selected on the bedrooms equal 2 clause, not on this clause. So just be aware of what happens when you use and versus or. The not statement is a little different. You do need to use some parentheses for this just to make it more clear. So we're going to select all of our fields from the owner table. Our where clause is going to be not, and then in parentheses we're going to have the criteria we don't want it to meet. So in this case we want all of the owners except for those that live in Florida. Remember, equal sign, and I do have my single quotes. So I run that. I get all of my data that I requested, and if we go over to our state column, we notice that none of these owners live in Florida like we requested. All right, moving right along, we have the between clause. This allows us to select values that are between numbers. And so in this one, if we want to find all of the condos that are between an upper and a lower limit, we can use the between clause for that. So we're going to select the unit num and the amount of square footage from the condo unit table, where the square footage is between the values of 700 and 1200. So our smaller condos and our larger condos shouldn't be selected with this query. So notice all of our square footage meets the criteria on the between. You can also add, you can average fields, and there are quite a few examples in your book and in the notes and PowerPoints from this. What I'm going to do real quick is do a real quick one where I sum the fields up, and I want to do it with and without a modification. So I'm going to go ahead and bring in my query. And what we're going to do is we're going to select the unit number, and we're going to add the bedrooms and baths together from the condo unit. So notice some things. So 102 hopefully is a 1 bedroom, 1 bath. Let me look that up real quick. It is a 1 bedroom, 1 bath, and so it adds those two things together to get 2. Condo unit 201 is a 2 bedroom, 1 bath, so it gets added together to make a 3. Now, if I want to change the way this displays, I can add another clause using as, and I can give it a new name. So I can say I want to add those two together, and I want to display them as a column named rooms. Now, this is not saved in the table anywhere. It's for display purposes only. So when I run it, it's the same output with which records are selected and how they're added. But now I have unit num here, and I have rooms here instead of the bedrooms plus bath that is actually part of my query. All right, let's do wildcards. So I'm going to do an example with the like wildcard. There's an underscore wildcard too that substitutes for just one missing character. So the example I think it gives in the PowerPoint is T underscore Tom would retrieve Tim, Tom, Tum, but it wouldn't retrieve Thumb or something like that. It can only replace one character at a time. More times than not, you're looking for things that are a little loosey-gooseier. And so we're going to use the AND clause. And so what I'm going to do is I'm going to do a query that's going to try to find owners that have first names with AND in it, indicating that it's a couple. Again, this is bad database design. You should have these in probably separate rows that verges on repeating values, but we're going to let it fly. But first name, if you notice, like the first condo is owned by Bruce and Jean. So let's pretend that I wanted a list of all of my condo owners that had more than one person in it. And so what I'm going to do is I'm going to use the like operator. So I'm going to use like, and I have my parentheses around this, and the percentage sign here is going to represent multiple things that it could replace. So in this case, I'm hoping to retrieve Bruce and Jean. So this percentage sign will actually hopefully retrieve what I'm looking for, because that percentage sign will take this the place of Bruce space, and this one will replace the space Jean. So I'm going to run this, and I'm not going to get any results. I'm warning you right ahead of time. So I got no results. But if I look at the table on page 15, I see specifically Bruce and Jean there. This is one place where you do have to pay attention to case. It is literally looking for uppercase A, uppercase N, and uppercase D. And it's not finding it because the word and between the names is in lowercase. So let me take my caps lock off. Let me change that to lowercase and let me run it again. And this time I get my list. Now this is not foolproof because if somebody's first name had been Brandy, the percentage sign would have replaced the BR and the Y. So even that would have needed a little bit more work, but I just wanted to show you how it does work. I'm going to do another example. Let's say that I want all of the owners whose last names begin with B. It's going to be very similar. I'm going to select their first name and last name from the owner table, where last name is like, but notice what I do with the percentage sign. Instead of having a percentage sign in front of the B and a percentage sign after the B, I just put the percentage sign after the B because I only want characters replaced after the B. If I were to put it here in front of it, then anybody who had a B in their name, in this case it would have to be a capital B, maybe an O'Brien, that would be retrieved also. So I want to actually put the percentage sign where I want the characters to be replaced. So I run this, and there is Jack Blake with his B starting first name. All right. So the in statement. The in statement is useful when you have multiple options and they're not really ordered. If you have a between values, then that's real handy and you can use between. But let's say that we want to find all of the owners that live in 3 different states. We can do or statements. We could do select first name, last name from owner where state equals Florida or state equals South Carolina or state equals Michigan. But there's a quicker way to do it using the in statement. And it looks a little something like this. You are going to need some parentheses, but we're going to select first name, last name, and state from the owner table where our field is in, and then in parentheses, I have my values separated by commas. Now, if this were for some reason numerical, I wouldn't have those single quotes. Remember that. But what this will do is it'll retrieve everything from the owner table where they live in either Florida, Michigan, or South Carolina. So we'll watch that one play out. Florida, South Carolina, Michigan, and those are our 3 choices. So notice these are out of order. They're retrieved in the order that they live in the database. What we're going to look at now is how to order those things. We're going to do a different query though, of course. We're just going to select all of, not sure why I did a paste like that, but we're going to select first name, last name, and state from owner, but we're going to order by state. And so what you do, order by is the clause that is your sorting clause. It sorts ascending by default, and then it will just go into the state field and sort those. So we run that. We have all of our users. Florida is alphabetically first, followed by Georgia, followed by Michigan, followed by Pennsylvania, South Carolina, and that is all. If I wanted to if I wanted it in reverse order, I would just add the descending clause, and that would run, and it looks like I have an error. Order by state, the descending has to go after what you're ordering by, not paying attention. So order by state, descending. All right, so this is why I'm copying and pasting for y'all, so you don't have to watch me make errors. So we run that. Our same set of data, just ordered by state in reverse order. Okay. Now I can order by more than one thing. So we have quite a few people here from Florida, but notice after it sorts by Florida, it doesn't do anything. I could sort by last name. I'm going to go ahead and add the city instead, and I'm going to sort by state. then city for some reason. Don't know why, but I'm gonna. And so I run. So let's go, I still have my descending, so let's go down to our Floridas. It sorts the state descending, but then because I don't have descending added to city, by default, it will sort that ascending. So the Boughtons come first, then Glander Bay, and then Kaliva. So these get all sorted after the state gets sorted. All right. So the next one is actually very useful in answering questions that your boss comes to you, or your client or your sales team comes to you and they say, how many people fill in the blank? And so what you can do is you can count how many records meet a certain criteria with the count clause. Now, this is a little weird. This is how you'll see it written most of the time. Select count, and in asterisk, you're going to count all. Okay, you're going to count all fields. It'll just count records, but you could put in count custom or whatever you wanted to, but 99% of the time when you're counting, you'll see an asterisk in there. So you're going to select count from the owner table where state equals Florida. So this isn't going to return any fields. We're not going to see Bill and Sandy, and we're not going to see Jim and Kathy. We're going to see the number of people that live in Florida. So I missed the S. So I run that, and notice down here my query result, there's one row, but my count is 7 people live in Florida. So I could select and have my fields shown as well, but that's going to mess up your output. Most of the time your count is just going to be exactly that, a count. You can summarize, you can add, or you can average. So one of the examples I think on the TAL database is to average the number, or average the balances of customers per rep or something like that. What I'm going to do is I'm going to run a query that, but if I can copy and paste, I'm going to run a query that sums all of the square footage. So we're going to take everything from the condo unit, we're going to sum all of the square feet fields in that and find out how much square footage we have. We get one line of output with 15,902. And we'll come back to that when we start to group. In a minute, we'll figure out how to get it to tell us how much square foot is at each location. But we're not quite there yet. The next thing we're going to look at is the distinct. Now, depending on how your data is distributed across tables, when you do a query, you might get repeating values. For example, a condo might have 4 different service requests out on it. And if you said, list all the condos that have a service request, then it would show that 4 times. You would get output for each of those. But if I just want a list of the condos that have 1 to X number of service requests on it, what I want to do is I want to do a distinct. So I'm going to do this first without the distinct, and let me show you what I mean by this. So let me take this out real quick. I can leave those parentheses there, I need them. So what I'm going to do is I'm going to select condo ID from service request. So this is going to show me all the condo IDs in that table. Okay, I lied. It doesn't like my parentheses. Select condo ID from service request. All right, so here's what I mean. Condo ID number 2 has 1 service request, and down here it shows up again because it has a second request on it. And I think we have another, I think number 9, condo number 9 also has 2 entries into the service request table. So if I really just wanted a list of these, then what I could do is I could use the distinct operator that says, don't show me duplicates is really what it's doing. So let me go ahead and order this by condo ID so we can see. So now we get the list, but 2 only shows up in the list once and 9 only shows up in the list. Right. So if I, like using the tall database, if I had a request where I said, show me all the customers that have ordered puzzles, well, if I had a customer who had ordered puzzles 52 times, I don't want to see that customer in my request 52 times. I want to see a distinct list of customers who have ordered the puzzle instead of seeing how many times they've ordered the puzzle in the same request. All right, we're getting close to the end of our options in this chapter. What we're going to look at now is a subquery, an in statement, and it is a subquery that does one query and then another query against those results. So this is actually going to use data from 2 tables, but it's going to do it one at a time. And the way this works is we're going to select the condo fee from our condo unit table, where our condo ID is in the results of a previously run query. So this works kind of backwards. So let's talk about what's going to happen. When we go in here, this subquery is going to run first. We're going to select the condo ID from the service request table where spent hours is greater than 1. So this right here is a single table query. It'll go into our service request table. It'll find all of the requests where hours spent was greater than 1. In this case, there's only 1. And it'll return the condo ID. So if you look at the table on page 17 in your textbook, notice that the first entry in the table is the only one where spent hours is greater than 1. So it's going to run this query and it's going to return condo ID number 2. So the in statement will be used to select that. So pretend like this equals 2. Now in the real world it could equal multiple things. But what we'll do now is we'll go select condo fee from the condo unit table, which is a different table, where condo ID is in this subgroup. So what it does is it says condo ID is 2. So now what I'm going to do is go look in the condo unit table. The only returned record here was 2, so it'll go look up the condo fee, which should be $550 for condo unit number 2. Okay, this is not ideal. A lot of times we'll join these tables together in the next chapter and have a whole lot less typing and a whole lot more flexibility. But this is a way to do in statements. You run one query that has results, and then you run another query against that set of results. And down here we do see that our condo fee is $550. All right, we now have to talk about grouping. So sometimes when you use those aggregating functions like averages and sums and things like that, you want to do it by grouping. And so like if we had a list of students, we might want to find what their average exam score was over 3 exams. And as a result, we would need to group it by students. In the tall database, we might want to look at the average balance of customers by rep number. And then what we're going to do here is we're going to go back to our square footage and we're going to average the square footage of our condo unit but we're going to group it by location, which means that it's going to average based on what our grouping number is. So it'll group the two different locations and average those numbers for us. And you just have a group by clause added to your queries. So we're going to select the location number. In our Solmeris database, we only have 2 locations. We're going to average the square footage from the condo unit table. And this is what we added. Before adding this, it would have given us the square footage for all locations. We did this query previously and it was like 15,000 or something like that. But when we group by location number, what it does is it says, okay, what's the first location number and what's the average of square footage that meets that criteria, and what's the next location number and what's the average square footage for that. So in this case, because we have 2 locations, when we run it, we're going to get 2 different entities. So location 1, which if we were to look on our location table is Solmeris Ocean, the average square footage there is 1184 and some change. And then in our second location, Solmeris Bayside, condo units are a little smaller on average at 1,071 square feet. To make this more complicated, we can have a having clause on our grouping. Now this is very important. Having is always used with a grouping. It's kind of like the where statement for grouping. So we're going to do a similar query. We're going to have location and we're going to average square foot from the condo unit. We're going to group by location, but we only want the results to show up if they meet this criteria here. So before we run this, we're going to say greater than 1100, which means that this one, the result of this 1071, will not meet this having clause. So when we run this, the only thing it's going to do is show us the square footage for that first location. Okay, so the having statement is like a where clause for groups. All right, it's very important. If you did where average square foot is greater than 1100, then you're going to mess up this selection up here. This shows us which group we're actually going to display. So when we run that, it turns out exactly like I told you. But it's very important. There are a couple of slides in the class notes on the difference between where and then having, and I highly recommend that you take a peek at those so you get those 2 straightened out in your head. And so the last 2 queries we're going to do for this chapter have to do with looking for null or not null. There are hundreds of times where you need to figure out where data is missing, or you want to select based on something. So you're going to send out birthday cards to your clients and you want to only select those customers where their birth date field is not null. Or you're going to update customers and you want to find out where something is null. And so real quick, you have just basically as an is null or an is not null statement. So we can go into the service request data or service request table. We're going to select all fields and we're going to select where the next service date is null, which means it's empty. So if you look at the table again on page 17, you'll look at service ID number 5. The next service date is empty, and service ID number 7, the next service date is also empty. So when we run that, hopefully we get those 2 that I indicated. If we add not null, it does the exact opposite. It retrieves all of the data from that table that actually has data in it, and it leaves out number 5 and number 7. So we'll run that. And you can see 1, 2, 3, 4, 6, 8, 9, 10. Okay, so that is a whole bunch of information in 34 minutes. I wish it was a little bit shorter, but there was a lot to learn there. Practice, practice, practice. You're going to get a lot of practice in your assignment. You'll have more practice on the midterm. But looking forward, we're going to move on to joins, and we're going to spend a lot more time on that because it gets a little bit more complicated when we start putting these tables together. So get started on your homework if you haven't already, and ask questions if you need to.